NITK's first workshop of the year on computational physics. I'm Dhriti, a third year student member and the club's scientific tutor coordinator for this year. And the person who will be taking today's session is Shobut Paul, third year mechanical student and AAC's physics SIG head this year. Next slide, please. Okay, so we've all heard about computational physics, but any idea what it is actually about? So it's a field that uses numerical analysis to find solutions to all physics-related problems. So today's workshop will be actually divided into 4 segments, which will be held over the next 3 days, including today. And all the topics are will be given on the screen, which we will be covering over the next 3 days. And the main idea why we divided it into 4 separate topics was to make it extremely beginner friendly. So all the newbies out here today, we've got you. Next page, please. So these are the 4 different topics that we'll be covering over the next 3 days. The first session, which will be today, is on the Python basics and libraries for data visualization, mathematical and matrix operations. Yeah. Next slide. So this particular knowledge sharing session will be extremely useful to all those who are planning to get into research, especially core engineering research. It includes programming, a lot of mathematics, and we'll be covering the basics of algorithms as well. So anybody who is tech savvy or ready to get into the physics related field, this computational physics knowledge sharing session is just right for you. Today's session's chat box will be open for you all to ask any kinds of doubts. So all questions will be either addressed during or after the session. So let's begin with today's session and get the learning started.
Thank you, Dhriti, for that wonderful introduction. Now let's start with the session itself. I will be sharing my screen in just 1 second. Okay, so hi everybody. As Dhriti introduced, I am Shobush, third year mechanical engineering, and I am very much interested in all things to do with physics. Mostly not because I want to become like a theoretical string physicist or something, but because I like the fact that how physics relates to all and every part of our engineering curriculum. Without physics, there would be no engineering. Now, why computational physics? So that might be a question. Why not something a little bit more, something that sounds cooler, like maybe relativity or something? A, I'm sure a little bit of that is already covered in your curriculum. And B, computational physics is something that you will find use of no matter which field you go into. Okay, so that is why I wanted to start you guys off with computational physics, and B, this sort of mathematical thinking, this sort of program, a little bit of programming skills, a little bit of algorithmic knowledge. This sort of stuff is necessary no matter what you do, and especially very very necessary if you are in your circuit branches or your core branches. So anything to do with fluid mechanics, heat transfer, dynamics, vibration, chemical process engineering, material, what do you call material science, then your uh, transport phenomena, everything and anything requires these numerical methods. In fact, the very sophisticated engineering tools that we use these days, such as ANSYS or you know ANSYS Fluent or other simulation software such as LT Spice, when for electrical circuits, everything has been built on the basics of numerical analysis. So let's get started. First thing is, as you guys know, there is this repository, which is linked also linked in the yeah, it's also linked in the WhatsApp group description. I have just pushed the session one codes that are right here for all of you guys to take a look at. Uh, so I want the session to be as hands-on as possible. So if you want, you can go either way. If you're familiar with a little bit of Git, you can clone this and start working. If you're not familiar with Git, then you can just copy out these blocks, paste it in your in your notebooks, and keep working with me. Or if you're working with Colab, there's even a simpler way. So basically, you go to your drive, you go to your Google Collaboratory. Um, taking some time. Okay. So, um, okay, you can go to Open Notebook, GitHub. Now here, just copy out this link. Go to your the main branch of the repo. Copy out this link and paste it here. Search, and this repo will automatically show. So here underneath all the Python notebooks that will be inside the repo will come up. So suppose for the first session, this Python tutorial notebook is there. You can open this up. Now, if you try to make changes in this thing, suppose you cannot save these changes. So there's no, but I'm assuming you would want to save the changes. So in that case, you do this copy to your drive, and this would create a local copy in your own Google Drive folder. And yeah, so here now you can begin executing your commands, and and those changes will be saved. So that is for your Google Collaboratory. Obviously Google Colab is very convenient when it comes to Python programming. I personally prefer offline notebooks, more specifically VS Code. So I will be continuing here. If you have any doubts in between the session, if something is not working right in the Colab notebook, please feel free to put it in the chat, and we will take it up whenever we stop for doubts. Okay, so since everything is now set up, let's get started. Okay, so Python. So Python is again like your there's various programming languages: the C, C++, Python, Dart, Java, JavaScript. The list keeps going on and on. Python is most suitable for scientific computation. Why? A, it is very easy to write. B, it has numerous libraries for all kinds of computational work. And C, uh, it has good performance when it comes to dealing with large data. Okay, now let's see. Yeah, let's start with the basic declaration and data type. So in Python, you don't need to declare your data type as such. It automatically, infers what the data type is depending on what you are assigning it. Okay, so there is int data type, there is float data type, there is string data type. Int is basically just your what do you call, your 32-bit integers. Here in this case, I'm assigning 3 to A. Five float is your again your decimal point numbers, in which case you can assign these to these values. And strings are basically your words and characters and such. Now Python has this very good way of multiple assignment. You can separate these all variables with commas, you can separate these all variables with commas, and it will assign each variable to its corresponding value. So this works pretty well for us actually. And this is your okay, you can also do complex numbers. Your iota, that root of -1, that is represented by j here. If you have taken your basic electrical engineering class, there also it is assigned, what do you call, recognized by j. J is root of -1. And null, okay, none type, okay, here. None type basically means, as the name suggests, nothing. Okay, so it is what is assigned when it does not have any of the other data types. Okay. Now let's run this cell. To run this cell, if you're not aware, you pressed shift and then you press enter. Okay. In that case, it will run this cell. Now, as you can see, we are printing A. We know we had assigned A. So print statement also we don't need to do much. Whatever object there is inside the print statement, it will just print it out without asking us for the what do you call, what data type value it is. Okay, here now type is a inbuilt function of Python, which is very important. It gives us, basically gives us the type of the data type that is that we are using. Okay, so one okay, so here x y z we had done by multiple assignment. So here you can see one is type int, 2.5 is type float, and this again this. Okay, now this is 3, but it is given within okay, single quotes or double quotes. Anything given within single quotes or double quotes will be of type string. And 5 plus 7j, this is of class complex. Okay, none is of class none type. Okay, so these are all basic data types. Python also is also very you can say mm, use what you call user friendly, and it also gives a very useful way of managing your code very well. Okay, so instead of having like loads of brackets and stuff like you do in C++, and sometimes if you don't write the code properly, it's very difficult to know which is which. So Python has mandatory this thing, your mandatory indenting. So here if I run this a equals 5, it will run. But if I similarly I run this thing, okay, this will not run. The code needs to be indented properly. We will see later on how this indenting is built into the language itself when we get into conditional statement and loops, but this does not work. Okay, now variable names. Again, I'm just going to leave this box for you. This is basically rules for what variable names can and cannot be. Now let's talk about basic input and output. Okay, I'm first going to run this cell. Okay, now I'm going to show you. So A and B we had declared before. So this is a combined output. Uh, that is whenever you're printing, you can write this sort of a string. You can do comma and you can put whatever values you have here. So this basically concatenates the string here. Concatenates, that's a long word if you're not familiar with it. But in programming terms, it usually means two strings that are joined together. Okay. You can also give some sort of these separators between these. Okay. Here it usually takes a space as a separate, one space as a separator. You can also give like a hash or something, and then at the end you can also give this sort of a dollar sign. Yeah, see. Okay. Here it's end, so here it's giving like this. Um, okay, yeah. See. Anyways, and usually at the end it usually gives you a new line character. That is, it automatically goes to a new line. But if you give this character, it will automatically come here rather than on the new line. Okay. And okay, these are your logical operators. Okay, uh, it's printing 8. Okay, if you print nothing within this, then it is just it's not going to give anything. Yeah, these are your these are your relational operators, and these are your logical operators. So relational, what does relational operators mean? How you relate to quantities. So 5 plus 6 greater than 3. Okay, so if 6 is greater than 3, basically this entire operation gives me a boolean value. Boolean value as in a true or a false value. So that is also what is printed here. Okay, it returns me, this whole operation returns me a true value since 6 is indeed greater than 3. Then this is a concatenation operation. You can add two strings this way in Python. You can also these are basic plus minus operations that you can do. Then these are your more relational operators. 3 is equals to 2. Since it is not, it will return as false. This will also what do you call, returns false. Okay, this okay. If you had just put this would return as false. But in this case, what it would happen? is it would check which one of this is true. If either of this is true, it will return as true, because that is how your OR works. Okay, and for what you call your AND operator, both of them have to be true for it to return true. For OR operator, either one of them, if it is true, it returns true. Not basically flips your true to false and false to true. So whatever this inside expression will be, it will just flip it. Okay. So here I can enter a string, say I will say hello. Okay. So this is a way of this is something called typecasting. What is typecasting? Suppose I have a variable, say 6.5. Okay, this is if I try to print the type of this variable. Okay, I will print both the variable as well as the type. Okay. I'll just for now I'll just comment this. Yeah, okay. About comments also. Basically, in Python, you can just put a hash in front of anything, and it'll it'll be commented. Commented means that code will not, the interpreter, Python interpreter will not see that as a line of code anymore. It's just there doing nothing. Okay. Comments are pretty useful if you want to give description about some piece of code you've written, and it is a good programming practice to always put comments. No matter what you're doing. When tomorrow session onwards, when you move on to the physics part of it, you will see that there's a lot of comments written on all of my programming codes. Okay, so wait, yeah. Okay, so I will do this. So as you can see here, this gives a type float, but instead of this, if I want to do, if I typecast it like this, I will do this. B is equals to int a. So this is typecasting. I am basically changing it to from float to an int. Okay, and then I try to print this thing. Now you can see this decimal point was removed and it was converted to type int. Can I do the same thing with my string? Okay. Now I'll comment out this part. Again, I put hello. Okay, as you can see, string values cannot be changed to integer values. Okay. On the other hand, say this hello could not be changed, but what if I put 3? It changed. So Python is very dynamic in this scenario. It will not. There's a lot of nuances that goes into everything you do. So if you put a number in there, okay, an integer number, or it will give you, it will convert it to an int rather than a what do you call a string, like we had seen before. But if you put something like hello or something like a proper word, then it will not. Then we are moving on to conditional statement. What does conditional statement mean? Conditional statement basically means we are telling the compiler, if this particular condition is true, then do this. Okay. Uh, in that case, what happens is that the compiler will check the condition first. Okay, if it returns a value of true, then it will it will do whatever is inside the conditional statement. Okay. So here a is equals to 5. Okay. Now this part of the expression, this if statement, it does not exactly check what this part is. It does not care. Okay. But we know that this part itself, it returns true or false values. Okay, so a is greater than 3. What value would that return? That would return a true value, since a is indeed greater than 5 is indeed greater than 3. Okay, so it will check only if statements and while statements will only check if the value is true or not. Now that true, how to get that true or false depends on how you write the code and how your logical and conditional statements are arranged. Now if I run this, as you can see, since this value is true, it will increment. A is equals to a by 6. Now this is something, if someone has not written code before, they will find very jarring. Okay, they will say then this line of code is basically saying 6 is equals to 0. That is not how it works when it comes to code. It is always remember this expression, variable is equals to value. Okay, I will put it here also. Variable, oh wait, variable is equals to value. Okay, so what happens here is that whatever this value that it will first compute this value. Okay, what, and then it will assign this value, it will assign this value to this variable here. Okay, so a is first, it will compute a plus 6, which is 11, and then it will again update the value of a. Okay, so that is how stuff in and this is true for absolutely any language. That is how variable updation works. Okay, now what if I put it as 1? It will stay 1 because this condition returned false, so this was not evaluated, and it broke out of this statement and it just printed it. Okay, I can again put it as something like 8 and it will still execute this. I can also have multiple conditions. Okay, that suppose since a is equals to 4, if a is greater than 4, it will print a is greater than 4. Okay, or if a is less than 4, it will print a is less than 4. Else, okay, if a is not greater than 4 and a is not less than 4, what is left there? We can also put it like this: if elif a is equals to 4. Okay, so in this case it will give it will give the same exact same output. Okay, but since this is not really needed, since there are all the conditions other than this one is exhausted, we can just put else. So your if statement gives your first condition, elif statement gives your intermediate condition. Why elif? Because if you put if everywhere, what will happen? It will check each and every. What after checking each and every condition, it will also execute it. Okay, we do not want that. We want it. If this is not true, we want it to move to the next one. In that case, our compile time comes down. So that is why we use elif. Um, okay, and this is just else is for your last statement. By the way, I think I forgot to tell. There is, I'll come up here. I think, yeah. If you check your relational operators, okay, there is equals to equals, there is equals to, and there is equals to equals to. What is the difference between these two? Equals to is the value, assigning a value. Like if I say a is equals to 6, it will assign the value 6 to a. If I say equals to, in that case it will compare what a value is and what 6 value is, and it will again return me a true or false value. So do not confuse these two. It is a very common mistake to make, and it will give you all sorts of runtime errors. Okay, again, this is also similar to this. You can even have nested statements like this. Nested statement basically means, a whole chunk of code inside another chunk of code. That's basically what it means. So I'll run this. You can look over this on your own. Okay, now let's move on to loops. Loops are the most important part when it comes to any sort of algorithm. Okay, because algorithms in their uh, base form are basically iteration, like iterating upon your solution till it gets better. Okay, might not be true for all algorithms, but is definitely true for all numerical analysis algorithms. Okay, so that is why loops are very important. And in Python, loops are made extremely easy. So, okay, this is the here the syntax for a loop is given. For x in range this to this, you will print out this number. Okay, so this is the code for it. What does this thing mean? Range is again an inbuilt function in Python. It basically returns an object, an iterable object. What does an iterable object mean? That you can go from, if you have some, say, range 1 to 5, okay, then you can go from 1 to 5 minus 1. So range function, this end value is not included. Okay, so 2 to 8, which means it will print out 2, 3, 4, 5, 6, 7. You can check it out by running it. Okay, yeah, 2, 3, 4, 5, 6, 7. It'll print it out like this. Yeah, see, lower bound is always included and upper bound is always excluded. Um, there is also an additional argument here you can give in range, that is an increment. So if I don't want it to iterate by one, if I wanted to jump by two values, that also I can do. And in this case, you can see that is exactly what happened from 1 to 6 with a step size of 2. So 1 to after 1 it will go to 3, 3 to 5, and then it will stop printing because it can't go to 7. Um, Okay, again, as I've said, Python is a very dynamic language, so you can do all sorts of things in Python. One very great thing is in Python is you can also do stuff that is not really allowed in other programming languages, like giving negative step size or negative indexes and all. So you can go from 5 to -1. Okay, so yeah, not 5 to -1, -1 plus 5 to 0. Okay, since this the last one is not included, and it's going a step size of -1. Okay, so uh, yeah, see, 5 4 3 2 1 0. Uh, and if you just give it one argument, it will automatically assume the lower bound to be 0. Okay, which is usually the case in most of the stuff we do. We want the lower bound to be 0. Okay, now let's look at continue statements. Continue, break, okay, continue and break are similar statements. I'll run these two cells and then I'll explain it to you. Yeah. Okay, so the first is the continue statement. So when you are in a loop, okay, um, when you are in a loop, what will happen is sometimes you might want if you might want to break off in the loop and start again. Okay, if because of some condition. So similar to this thing, for x in range 1 to 5, if x is 2, for the value of x is equals to 2, it will break off here and will start again here. Okay. Now what loops essentially do is that it will go from 1 to 5. Okay, x will be first be 1, x will then be 2, x will then be 3. So when x is 2, it will continue and it will get back to here and it will keep printing this value. Okay, so as you can see, 1, it skipped 2 because it went back again, then it 3, 4, and then it printed y, then it updated y, and then it printed y. Similarly, break statement is also similar, with the difference being rather than going up, it breaks out of the loop. Okay, it does not update, since y is also in the loop, it does not update y. Wait, y between to break index. Okay, yeah. Uh, so y is 2. One second. Okay, I think I've used the variable y somewhere else. That's why it's incrementing like this. Uh, so be sure, do not make this mistake. Whenever you make, whenever you use some variable, make sure that it is unique within the code. This is one mistake I think I've made here. In that case, this y is not updating properly. So in this case, let's try out some other variable that maybe I would not have used. Let's try z. Okay. Uh, okay, it's still updating me. Okay, fine. Okay, never mind. I got the mistake. Okay, it is correct. It is correct only. It is basically it is updating every time it is going. So first three iterations are going. So and z starts from 0. So 0 plus 2, 2 plus 4, 4 plus 6, 4 plus 2, 6. Okay. Similarly, here also it iterates two times. Okay, uh, x is equals to 1, x is equals to 2, and at x is equals to 3, it breaks out of the loop. So y only gets updated two times by a factor of by step size of 1. So y is equals to 2. Then this is while loop. While loop is very similar to for loop. Only thing being for loop automatically iterates your value. Okay, within a particular range. or within a particular, you will see later in a list or a tuple or something. Okay, while just checks a condition. It does not iterate anything. So you might need to iterate it yourself like this. Okay. Um, okay, before we move forward, I'm going to stop for doubts. Are there any doubts here? Let me check the chat box. Okay, no doubts as such.
The chat box is disabled for most of us.
Oh, the chat box is disabled. Give me 1 second, man. Abhishek, can you?
I can't really fix it right now. I think
Okay, that's okay. If you guys have any doubts, you can just. Okay, maybe you can put it on the WhatsApp.
Yeah, we actually tried that.
Hello.
Yeah, we tried reversing the option actually, but we are not able to find, it's actually only members now. We cannot
Okay,
make it
okay.
for all the attendees. Yeah.
Okay, cool. That's fine.
So
In
if
that
you
case, yeah. In
raise
that case,
your
if you guys
hand.
want, you can either unmute and ask, or you can just put it on the WhatsApp group itself. Are there
Excuse
any?
me.
Yeah.
Like, can you explain the continue and break statement once again?
Okay. Continue and break statements. I'll come back again.
Yeah.
Okay, yeah, sorry. I guess, yeah. Okay, so basically, when you're going in a loop, so let's look at, okay, let's forget this loop for a while. Okay, let's look at a simpler loop for x in range 1 to 5. If print x and z is equals to z plus 2. Okay, do you understand what is happening here? Is it clear to you here?
Yes.
Okay, so in that case, what you do? So now this is very simple. So this is also similar, but what I want to do is I don't want to take update z when my x is 2. So x goes from 1 to 4, 1, 2, 3, 4. Okay, here. Okay, but I don't want to skip out 2. I don't want 2. So what will happen? It will check if x is 2. We put continue. What continue will do is it will first break out of this loop and it will go straight to the top. Okay, and then it will update again. So if every time updation of x, that is changing of x to 1, 2, 3, 4, it takes place here at the top of the loop. Okay, think of it like this. Okay, so when this happens, so we, as soon as we break out of the loop and go to the top again, we skip out on 2 because 2 did, at 2 z did not get updated, and it will but x will update to 3. Okay, now if I run this, you can see that 2 is skipped out. So my Z did not get updated one time. Is that clear now? Break statement is also similar, but in this case, what will happen? Instead of going to the top, okay, wait, sorry. Yeah, instead of going to the top, it will just break out of the loop permanently. It will not go back. So in this case, for range is 1 to 5, or 1, 2, 3, 4, x takes these 4 values. Once it takes 1 and 2, as soon as it reaches 3, it will break out of the loop. Okay, it will not start again. Is that clear?
Yes. Yeah. It's clear.
Okay. Any other doubts? Feel free to put in the WhatsApp chat, or unmute and ask. I would feel very good if you guys unmute and ask. It's much more interactive that way.
Sir,
Don't call me sir, please. I'm just heard you. Go on. Yeah.
in break statement,
Yeah.
if we want to break two or three numbers, then
What do you mean 2 or 3 numbers?
means we have to break 3 and 4.
Okay. So suppose, okay, I'll change this a little bit. Let's see if I understand your question. So suppose my x takes values of 1 to 5, and you want to break out of, you wouldn't want 3 and 4. Am I correct?
Yes.
Okay. So here then in that case you will not use break. You will use continue statement. So suppose my x goes from 1 to 5. Okay. So if x is equals to 2, or x is equals to okay, you said 3 and 4, or x is equals to 4. Okay, here if you run this, you can see it skipped out 3 and 4. Okay, what happened here is it first x was 1. Okay, it checked the value if x is 3 or 4. It's not, so it printed 1 and it updated z and it went back up. Now x is 2. It came down, it checked the value. It's not 2, 3 and 4. It printed 2 and then it updated z. It came back up. X became 3. It checked if x is 3, it will come down, it will print, it will not print because it has now gone up again. Okay, that is what continue statements do. Similarly, it will become 4, it will come down, it will check, it's not 4, it will go up again, it will become 5, it will come down, it's not 5, so it will print 5, it will update z and it will break out. Is that fine?
Yes, sir. Thank you.
Won't we use AND operator? Won't it be if x equal to 3 and x equal to 4?
Okay. How do I put this? Okay. So x we need for both 3 and 4 to not be counted. Okay. What AND operator actually does, it checks both conditions simultaneously. Okay. Keep this in very much in mind. I'll also put this here in comments. AND checks both conditions simultaneously. Okay, whereas OR checks either one. Okay.
Bro, just say out your logic in your head only, bro. It's either like if x is 3 or 4, then don't print it. It's not if x is 3 and 4, don't print it.
Yeah, so that is pretty much correct. Okay.
Yeah.
Any other doubts are there? Hmm. I will wait for another minute. If there are no doubts, I will move on with the session. Okay, cool. Okay, you can also use continue statements in while. Okay. So basically your continue and break statements both work with your these loop statements, or all of these together are called control flow statements. Okay, because they control the flow of your entire code. In Python, this thing is called a script. So it controls the entire flow of a Python script. Well, yeah, okay. I'll run this again. I want you guys to take a look at this yourself and come up with the logic. So while is again the same as for, but you update the value inside the loop rather than at the top. Okay, now we get into a very important part of Python, that is lists, sets and tuples, but we will not cover this in detail. Why? Because lists, sets and tuples are a inherent data type in Python. Okay, and they're very important if you want to do build a new library, or do some native coding in Python, or maybe build an app or something. But it is not very useful to us. What is useful is the NumPy library, which we will be moving on to in a while. So the NumPy library is built on these basics. Okay. Now I have a lot of code here. I will explain all of this in brief, and you guys can again take a look by it on yourself. Okay. Okay. This is a list. Okay. So the thing about lists is that they are they are basically arrays of objects in Python, and they can be heterogeneous arrays, which means you can in one list you can have you can have a integer, you can have a floating value, you can have a string, you can even have a numpy array, you can have a list inside list, you can have a set inside a list. So it's basically a very heterogeneous array. So this is one way to declare a list. This is another way to declare a list. Okay. um, okay. Now I was talking about the range function. So what is the range function? Is it a list? It's not a list. It is a data type of its own, just called range. Okay, and it's printed in this way. But we can typecast range into a list. Okay, we do it like this. All typecasting takes place in a similar manner. Instead of list, we want it int, use int. But iterable objects can only be changed into iterable objects, nothing else. Okay. Uh, and again, as I was talking about range ABC generates a range of numbers from A to B minus 1 with a step size of C. Again, this I've already explained. Now you can see this now becomes a class list. Okay. If I print out, I can also print out C. Okay. Yeah, I can also print out C and D. Okay. Well, C is basically your just your empty list. Empty list show up in this way. D is your range, the list that we created from the range data type. Originally, D looked like this. Now it looks like this. Okay. And the separator minus one basically means every output on a new line, in case that wasn't clear. So again, Python, I'll repeat again, very dynamic language. You can do a lot of things with it, whatever you want. It's very intuitive. So if you want say 5 zeros in a list, you do, you put 1 0 and then you multiply it with five, you get 5 zeros. Similarly, you can, as I said, you can put lists inside lists also. These are called nested lists. Again, you typecast a range object into a list. You can print it out. It will come out like this. But if you want to get individual elements, okay, what do you call this is basically your iterator. What is an iterator? It is basically sort of like a temporary variable that goes up from a particular value. So rather than using range, you can directly also use a list. Okay, so basically what we'll do, this is index 0, index 1, index 2, index 3, index 4. So it goes from whatever is the length of the list. Suppose the length is n, it goes from 0 to n minus 1. Okay, so that is your list. And okay, so so you can get every single item. So this statement again is sort of useless here, you know but what if I put 4 here? Okay, then it will only print out these values. Okay, so suppose I want, usually you put this sort of a statement if you want some non-negative numbers in some program or algo you're writing, something like that. Yeah, that is simple enough. Now let's get into slicing. Now slicing is a very intricate thing to do with lists, and I myself have to still look up documentation whenever I am trying to do something complicated with slicing. So slicing basically means you can how to access an array. Well, that is not slicing in itself, but accessing an element in Python, okay, of an array. Slicing is a very important part of that. So you can you can slice a list and get a part of that list. Okay, that is where the name comes from. So suppose a of 0. I have a list A and I want to get the first element. The first element is 1. So as I said, it starts from 0 to n minus 1. These are the indexes. Okay, the 0th element, the first element actually starts from 0. Similarly, the last two elements. Again, Python, very dynamic. You can't do this sort of things with other, you will never be able to do this sort of thing with C++ or Java or something. But in Python, you can do this. This last element, if you want, you can put -1. Okay, then it will circle back to this. This is basically your basics of a circular queue. If you guys are familiar with the term, if you're not, check it. Okay, if I want from 1 to 4, okay, if I wanted to print from 1 to 4, 1 not included, okay, then it will print like this. Remember, in your range function, the end is not included, okay, but here this thing gets included. What do you call this thing is included? Oh wait, no. Yeah, sorry. Yeah, in the range function, the endpoint is not included, but here it is included, the endpoint. Okay. So here it will start from index 1 and go till index 4. Okay. Wait, no. Okay, wait, never mind. Never mind that statement. Okay, it will go from index 1 to 4. It says 1 to 4, which means 1 to 4 minus 1. Okay. So your array, original array had what? Okay, 1 to 5. 1 2 3 4 5. In that case, it will start and stop at it will get the first index 1, index 0 1 2 3 4. Remember that. If you want, I'll put it in a comment here. 0 1 2 3 4. These are the indexes. Okay, so it will get the index 1, it will get index 2, and it will get index 3. So it will go from 1 to 4, or rather 1 to 4 minus 1. Now I want to give it only from the starting to the end. Okay, in that case you will use syntax like this. This is also slicing. Okay, so it will start from index 2, which is your number 3. Okay, and it will go till the end. Similarly, if you want it to start from the first element but go till a particular this thing, you can just put the last this thing. You can also do negative slicing like this. This I will leave to you to figure it out. Okay. This is okay. So this is your array A. So what I want to do is I want to print out all the elements. I want B to be a list. Okay, and this is a very useful way of declaring a list from an existing list. Okay, so for x it will be assigned the value element x for x in range 11 if x percent 2 is 0. What does x percent 2 means? It means that when you divide x divided by when you do x by 2, it will give you the quotient, and when you do x percent 2, it will give you the remainder. So I put in a comment here. This gives remainder. Of it. Okay, this gives the remainder. So here you can see that these two arrays turn out to be exactly the same, so it returns the value true. And now these are your this is this is again your nested list. Okay, it basically this one outer list is there, okay, which holds another 3 lists inside. Okay, so for usually in your classic programming languages, what you do is you iterate, you make 2 nested loops and you iterate through each and every element. First you go into this list and then you will iterate through all 3 elements, then you go to list this, then iterate through all 3 elements, stuff like that. Okay, Python gives you one-liner code for this called list comprehension. Okay, for item for sublist in main list. So this is our main list. Sublist is again like just a temporary variable declared. An item is also a temporary variable declared. Okay, so if you comprehend this line, you can comprehend this line carefully. Okay, this is basically saying that this is basically the same thing as this. That go into this loop, this list, and print out these elements. Go into this list, print out these elements. and if you see, they give out the exact same value, and then you can even slice it like this, if you want. Okay, then let's get into a couple of very good inbuilt functions in lists in Python. len a will give the length of a list. It also gives you the length of a string. Okay. A dot append 4. So if I have 1 2 3 4, this function will add 4 to the. It's better if I explain like this. Yeah. Okay. So okay, now this gives me my appended list. Okay, B is declared like this, but B dot clear removes all the elements from this list. So it just gives me an empty list. Okay, so D is declared here, B is equals to D. So same, the whole values of the list that is now given to B. Okay, now so expect B to be this thing, and D is appended here. Now if you check B, wait 1 second. Okay, yeah, so this is what happens. So your what do you call it? Instead of creating a copy, what it does is that in Python, uh, this B becomes becomes the same value as D every time even D is updated. Okay, so we expect B to be this, but it come every D, since D was added, it becomes this, but we don't want that. So in that case, what we do, we use this copy function. Okay, this creates a copy of D, in which case we can see that C does not get updated here. Okay. uh, okay, so here again, this is a D dot this count function, that is a what do you call it, member function of the list class, which gives you basically the number of times an element appears in in a list. Okay, and this sort of curly brackets are another way to give your print out a variable value inside a print function, as in giving commas or pluses or whatever. This is actually a better way to give your variable values. Okay. uh, yeah, so you can also append an entire list to what do you call to another list. Okay. Yeah, you can also append an entire list to another list. So suppose this is my list 4 5, I wanted to append to A. Okay, so I want 1 2 3 4 5, but when I try to do this A dot append, what it will do is actually it will stick the entire list inside A. Okay, so what do we do that? For that we use extend function. Extend function, what it does is it gives us this desired value. Okay, so as you can see, lists in Python, they have a lot of inbuilt functions. They have a lot of inbuilt functionalities that don't, for which we don't have to do a lot that we have to do in other programming languages. Like building loops or coming up with complicated algorithms. It already gives us a inbuilt function for all of these things. Similarly, I'll run this also. This is your insert function. Okay, it will insert a value that you've given here, okay, in your second argument at the index value of the first argument. So here inserted is this string is inserted at the second index. Okay, what does pop do? Basically pop removes the element at the specified position. Default is -1. -1 means the last element. It will remove the last element. Okay, and you can see before and after pop what happens. Okay, and it basically after removing the element, it returns that same element to returns the same element. What does return mean? You can make a statement like this, okay, and whatever element is returned from pop, it will be assigned to B. You can also use the remove function, which removes the first items with a specified value, but does not return it. So this I cannot write. Okay, if I try to write this, B will come out to be none. Because it does not return anything. Okay, if I can also reverse a list like this, that is pretty self-explanatory. Okay, I can sort a list. Okay, sorting means if I have a list which is of integers, say 1 to 10, which are in jumbled, and I want them to be sorted in suppose an ascending or a descending order, I can use that, and I can get a sorted list. So it was 3 to 1. Okay, and I wanted sort in ascending order, so I put reverse equals to false, and it will come out to be in ascending order. Okay, and if I suppose want it in descending order, in that case I put reverse equals to true, and it will come in descending order like this. And then if you run this thing, it will basically delete A. What does del A mean? A does not exist anymore. Okay, and that is why you get the error that A is not defined. Now this is all about lists. Tuples and sets are again very, I will just give you the definitions and I will tell you to go through them on your own, because they're not that hard once you get to know about lists. Tuples are basically immutable lists. What does immutable list mean? It means once you declare them, you cannot change them, you cannot append to them. Okay, so as you can see, this append would give me an error. Okay, so yeah, so if you declare it like, okay, so and tuples are given, by this round brackets. In that case, if you declare it like this, it will just, become an integer. Since we cannot, or if if you give it something like this, it will just become an integer. We don't want that. For that, we always put a comma here. If you want a single element declaration of a tuple, or or declare it like this. Okay, the rest of this I will leave to you. Sets. Now, what are sets? Sets are arrays which will hold unique elements. They are homogeneous arrays which will hold unique elements. So all of these elements, what do you call? Oh, sorry, they are not necessarily homogeneous, but they will hold unique elements. What does unique mean? Means since there are two circles here. Okay, if I print this out, this is a list, okay, which has two circles here, two circle same element repeated twice. If I typecast this to set, it will only give me one circle. It will eat up the other one. Okay, so that was your sets, and that was the basic of your sets. And again, it is very similar to lists. There are some set operations which are very similar to your set operations that you do in maths. So your intersection, your union, your difference of sets. Again, given your competitive exams, I don't need to tell you about these very basic things. You can check it out yourself. One last thing to go in your Python basics tutorial is functions. Okay, how do you exactly define a function? So, suppose I want a function in which I will put a and I will get a plus 1. So in that case, it will, I will put increment a and it will return me this thing. So I will declare s equals to 5. Okay, I will put this s is equals to increment s, and it will give me 6. Okay, I can also give this sort of an add function. So these are basically the arguments that you put in your function. So in your, like, maybe on a single variable or multivariable functions in mathematics, so you put f of x, right? It is something similar to that. So these are basically the arguments that you put in your function. So you can get these sort of functions. You can even have functions on strings. Now sometimes arguments can be default, like if you don't declare an argument like we have done. So suppose for a range function, the default are start value is taken to be 0 and the default separation value is taken to be step size is taken to be 1. Similarly, here also we can give, if we assign the value here, it is taken as a default value. So even if we don't declare it, it will give us the same value. Okay, so this basically wraps up your Python basics. We will move on to libraries after this, after like a 5-minute break. In that break, I will take questions. If you guys have any, please go ahead. Yeah, unmute and ask one by one, or you can put it in the WhatsApp chat.
Excuse me.
Yeah.
Could you please explain sort and sorted in lists?
Sort and sorted. What exactly in sort and sorted do you want to?
Could you please explain that again? Like, I didn't understand how they are like different from each other.
One second. Did I explain sort and difference in sort and sorted? Give me one second. Okay, yeah, it's here, right? Okay, so sort is a okay. So if you know a little bit of your object-oriented programming, you will know what is a member function, and you will know what difference between a member function and a what do you call it? A normal function. Okay, so sort is your member function of the list class. Okay, while sorted is just a function. Okay, which returns a list. Okay, so what a dot sort will do is that it will change the value of a itself to be sorted. But what sorted will give you is that it will it's basically a function that will return the value of, it will not do anything to the value of a itself. Okay, if you try to print a after this, as you do here, so a after this, it will remain exactly the same. Okay, but the value sorted will return a value that we can assign to a new variable. Is that clear enough?
Yeah, thanks. And it works only if the inputs of A are ints or floats, right?
Yeah. You try to put in what do you call like a string input or something, it will not work.
Thank you.
Can you explain the short form from sublist and main list, the shorter version that you used?
Okay, so sublist and main list. Okay, a list comprehension does take some time to understand. So here, so what do you do in classical list? Classical loops. For sublist in main list, okay, I will take a temporary variable sublist, okay, in main list. So I will go through the index 0, 1, 2 inside the main list. So first it is, okay, so that is what this loop is for. Then inside this each sublist, I will go to each item. Okay, for item in sublist, and if item is greater than 0, I will append it to item. So some operation I'm doing. Basically, that is how I operate. For list comprehension, what I do is this for item in a sublist. Okay, and sublist in main list for item in sublist if item is greater than 0. Okay. So this sublist again, this is one index in your main list. Main list has 3 major indexes. Okay, and item in oh wait, one second. Okay, fine. My bad here. I read this uh, reversed. Okay, so basically this item is returned to queue. Okay, this item value is being returned to queue, which is in sublist in main list. Okay, the sublist is in main list for item in sublist. Okay, and this item is in sublist. Okay, and it will return the value if item is greater than 0. It can be a little confusing if you think about it, but this is the portion that is returned. Okay, and this is the condition that is checked, and this for sub, this is basically what is doing the work of an entire loop. Is that a little bit clearer now?
Yes.
Any other doubts? Okay. If you have any doubts, again, you can put in the WhatsApp chat. You can, tell me, unmute and ask when I ask for doubts. Yeah. Okay. Then let's move on to libraries. Now, what are libraries in Python? So Python itself has a lot of features and things you can do in it, but obviously, like every programming language, it cannot do everything on its own, and it's not very feasible either. If Python had all of these functionalities, to load a single Python notebook would take forever. We do not want that. We want some basic functionalities to be in our normal Python environment, and we want to import out libraries that we might need for a particular script or a project or something like that. Or maybe if you even want to create our own library using basic Python functionalities for some special project that we are doing, maybe some for scientific computation, maybe for app development, maybe for machine learning, something like that. Okay. So, and that is precisely what most of your libraries are. So libraries like maths, okay, this math library is something that is native to Python. But the libraries that we are going to learn afterwards, like matplotlib and NumPy, those were not developed for developed within Python, or with Python. They were developed by external agencies, okay, or external open source organizations for use. So okay, let's go with math. Okay, again, math, not much introduction is to be needed. You know your basic mathematics, I'm assuming. So the ceiling function, it gives you your okay, I'll run this. And okay, math.ceiling function, it basically gives your the greatest the smallest integer greater than equals to the given number, okay, and that is for 2.3, that is 3. Floor function gives you the smallest integer less than or the greatest integer less than or equals to the given this thing, given variable, and that is for, in this case, is 2. Square root function gives you the square root, again no introduction needed. Log gives you the log of something given base 2, given base, okay, so in this case it just returns you 2, and all of this is done in O(n) time. Okay, uh, what does O of n time mean? Again, if you're not familiar with programming terminology, it might seem a little jarring, but basically it means it runs in linear time. Okay, linear time as in for some input n, it will take time proportional to how large that input n. It can also be proportional to the squared of that input, the log of that input, the n times log of that input, or maybe the root of that input. So these are all your runtime, what do you call, time complexities. Okay, so here all of these functions run on O of n. Uh, these are absolute values, absolute value function, power function. Again, no introduction needed as such. Okay, in Python you can also give infinity as a this thing. So float inf, okay, or float minus inf. This basically gives an gives you an infinity variable to work with, which is pretty useful when whenever errors and all need to be compared. Okay, so infinity is a object of class float. These are some maximum and minimum functions. Okay, my bad, sorry. Oh crap. Okay, yeah, see. So it will basically give you the maximum minimum of these whatever the inputs are. Okay. Now we will move on to something very important. We will be using this a lot in the upcoming sessions, and this is something no matter what kind of programming you are doing, whether for machine learning, maybe for robotics, maybe for what do you call computational fluid dynamics. This will be important no matter what you do, especially these days with the advent of data science, big data. The NumPy library is something that is used all over the world for in numerous applications. Okay, and we are going to follow along the same footsteps. So what does NumPy exactly do? It is a very powerful library, but it is a very simple concept. The concept is matrices, linear algebra. I want to do linear algebra computations, okay, in Python without, in the most native way possible. Okay, so I want to make a matrix. I want to be able to multiply two matrices. I want to be able to find the eigen values of a matrix. I want to be able to get the dimensions of the matrix. That way, as you know, when you try have some, you can even solve linear algebraic equations using your matrices. Okay. So when I have a matrix, okay, of when you have some thousand equations with 1,000 variables to solve, it's not exactly very comfortable to do it by hand. So you can use a matrix to find its find a matrix to get all the coefficients, and find its inverse and multiply it with the what do you call pre-multiplied with the other side of the equation, and get your this answer, the x vector and stuff. So that all stuff you've already covered in your matrix and linear algebra class. Okay, so first, to do anything I need to import the library, and the statement is very simple. Here also in math also we had imported the library. The statement is again nothing that big. We can import the NumPy library with another name. Usually it is imported as NP, which is very useful. Okay. A is equals to np.arrange shape 35. Now what does this mean? It will get me 15 values. Okay, 0 to 14. Okay, those are 15 values, and it will reshape it into an array of 3 rows and 5 columns. So as you can see, this is an array of 3 rows and 5 columns. Now what is the difference between a list and an array? You can see, if I printed out a list in this way, okay, it would have come out as one single list where these 3 lists separated by commas. It is, do not confuse a list with an NumPy array. Okay, a NumPy array is something very specific and something very different. Okay, it might look same, it might feel same, it is not the same. So it will be printed in this way. So number of axes or dimensions of the array 2. It is a 2-dimensional array. It can be 3, 4, 5 dimensional, whatever. Dimension of the array 3. Again, the shape that we have given 3, 5. Total number of elements in the array 15. Type of elements in the array. Now you can in NumPy you can also give the type of elements in the array. You can give float, double. You can give int. So here it is int 64. By default, NumPy arrays are integer. Now you can create your own custom array like this. Okay. Never do this. Never forget the square brackets. Okay. Your whole array is based on your NumPy arrays are based are based inside the square brackets. If you forget them, this is wrong. Okay, this will give you runtime errors. Similarly, if I want to okay, yeah, this is another way to declare an array. Okay, I can give 2D array like this. Okay, I can separate them out with round brackets. Now I can also declare it like this and give my D type as complex. Okay, what does complex mean? It means your complex numbers. So similarly, 1 plus 0j, 2 plus 0j, 3 plus 0j, 4 plus 0j. Okay. If I just put 1 plus, say, 1j and print out, it will still give like this. But if I don't put d type as complex, what will happen? Let's see. It's still giving the same way. Okay. So again, Python is very perceptive as to when it comes to what the type is. But if I suppose I remove this now, it will just take it as an integer. Okay. So it all depends on what I use. If I have only integer value, but I want it to be a complex array, I will declare it. I can give the data type as complex. This np.zeros will give you an array full of zeros of the given shape, like this 3 cross 4 array. np.ones will give you an array of so this is, they have declared a 3-dimensional array. What do you call? Okay, np dot, okay, this will np dot full, this will create a constant array. Okay, something like this. Okay, so it's a 2 cross 2 array with all elements as 7. Okay, that is what np dot full means. So and np dot empty, okay, it will give you a random what do you call, random a random array based on the system state. Okay, if you know what that means, it's great. If you don't know, that doesn't matter. Let's move on. This will give you an identity matrix of whatever 2D. It will give you a 2D identity matrix with of n cross n. So np dot I n gives you an identity matrix of n cross n elements. So here you can see you get 2 cross 2 identity element. You can make it 3 and get a 3 cross 3 identity element. You can get it for however many you want. np.random.random based on some seed. So you can check out the random function. It is in itself a very big, it has a lot of functionality. So given some seed value, you can find a random function, random what do you call, matrix like this. Okay, yeah. As you can see, it's giving me random values every time. Okay. Okay, so it will again, this is np.arrange. So what this will do is you give it a start value, you give it an end value, and you give it a step size, similar to your range function. So it will, and again, last, this thing is not included. So 10, 15, 20, 25, this will, give you an array. Similarly, step size can also be float. It does not need to be integer. But in your range function, the step size needs to be an integer. It cannot be float. Here, there is no such limitation. np.linespace gives you, so suppose this is something that we often need in our when we are dealing with, suppose, spatial systems. Okay, we have a spatial dimension of, say, some some maybe 5 by 5 square of space, or 5 by 5 by 5 square of uh, uh, 5 by 5 by 5 cube of space. Okay, and we want to divide that cube or that square up into small pieces. Now we want to know, we want the number of, so we don't want to have to divide every time, depending on the number of this thing you want. So we can, there in that case, we can use np.linespace, which again, you have the start and the end point, but instead of the step size, this time you have the number of elements and calculates the step size also. So you can see here you have 9 elements. Here, as I said, you can have a 1D array, you can have a 2D array, you can have a 3D array. The number of starting bracket is a good way to know what dimension of array it is. You check the number of starting brackets. If it's 3, it's 3-dimensional. If it's 2, it's 2-dimensional. If it's 1, it's 1-dimensional. Or you can just, you know, np dot you can check that, say c dot shape function. Okay, if you do c dot shape, it will return the shape of the whatever the array is. So you can also, it can be any big array, and you can reshape it into any this thing. So this is a big ass array, and yeah, this is again a randomly generated array. A is a randomly generated array. The lowest value it can go to 0, the highest value it can go to 10. So it will need to generate 10 random values between that, and the size is 3 cross 3. And np dot full, okay, it will again give you, it will give you a 3 cross 3 matrix with the full this thing, like it was for lists. Now we come to the important part. You can you can take a difference, you can add, you can multiply, you can divide, you can square. There's a lot of uh, operations you can do with the numpy arrays themselves. So if the arrays are of the appropriate size, or rather than the same size, you can add and subtract them. If they are of the appropriate size, you can multiply them, and if they're of the appropriate size, you can divide them. Okay, you can okay, this is, you can square them. Okay, for in Python, square, powers have a very convenient form of, for multiplication you put a star, for power you put a double star. Okay, you can also use np.power function, np.pi, np.sine function, everything. All your functionalities are there. Okay, keep one thing in mind. When you say multiply here, if you multiply it like this, sorry. So if you multiply it like this, it will give you element by element multiplication. What does element by element multiplication mean? It will multiply 0 0 with space 0 0, 1 1 with 1 1, 2 2 with 2 2. Similar with division. Okay, similar with squaring. If you don't want that, we use this np.power and inbuilt functions of the numpy library, so that to what do you call, to have the appropriate answer that you want. Similarly, if you want matrix multiplication, okay, if you want matrix multiplication, you use this np dot dot function. Okay, and you will get a matrix multiplication a and b. If you have two vectors, you can of appropriate sizes, you can even get a cross product. Okay, then okay. Usually in our normal programming languages, if you use this sort of a statement, b plus equals to a, this basically means b is equals to b plus a. Similarly, it's a plus equals to b means a is equals to a plus b. Okay, so this does not work with arrays, this numpy arrays. Okay, um, but a is equals to a plus b works. Okay, so be sure of that when you're working with arrays. You can, these are also inbuilt functions of arrays. You can get sum of all elements, you can get the minimum element, you can get the maximum element. You can print out the axis. Axis means the so okay, let's print out a, that way it will be easier to explain. Okay, so you have this here a, what you call this thing. So you can sum all the elements along axis 0. Okay, along axis 0 means along your this vertical axis. Yeah. Can you please, can you please
100.
hello? Okay, never mind. Okay, yeah, as I was saying, it will sum all the elements along this axis. Okay, and here it will sum all the elements along axis 1, it will sum all the elements along this axis, and it will give you return an an array of all the sums. So along this it will be 9, 12 and 15. Along this way it will be 3, 12, and 21. You can check it out. Then universal functions, np dot square root of a. This will again take a square root of all the or each single element. It will take exponential of each single element. It will take tan inverse of each single element. This will take log of each single element. Again, don't need to tell much about that. These are all inbuilt functions. This is a mask. What does a mask mean? When you compare what do you call an array like this with suppose a number, so in normal math does not make sense at all, but here it can work as a mask. Now what does a mask mean? If any of you have worked a little bit, know a little bit of maybe image processing or some image processing, or maybe how Photoshop works, you can do thresholding. If some color is too bright, you can make it absolutely white, and if some color is too dull, you can make it absolutely black, something like this. So similarly this thing works. So if you have suppose an array with some within all of the values, so np.random.42, this gives you values within 0 to 1. So you can have values from 0 to 1, and you can check each element like this, and it will return you an array of each element being compared to this and returning a true or a false value. So it will something look like this. So this is basically a mask. Okay. Okay, you can also slice within your NumPy arrays. Again, slicing I've already explained. You guys can take a look at this by yourself. You can broadcast. Okay, you can broadcast an array. What does broadcasting mean? If suppose two arrays are not of the same size. Okay, this array, this is the first array. This is the second array. Okay, if suppose they are not of the same size, okay, but I still want to add them, the second array will be broadcasted into the first array size, which means it will increase its size. So this 1 2 3, it gets repeated thrice. Okay, 1 2 3 1 2 3 1 2 3 1 2 3. Okay, and it will add to this array after that. Okay, and you can see the sum is similar. So be very careful when you are doing your array operations. Broadcasting is very useful when it comes to your machine learning operations, and this is very interesting. Okay, but you have to be very careful because during debugging you have to know that arrays have to be the same size. They might be broadcasted like this. Then vectorization. Okay. Okay, so this is basically giving you a time. So okay, I can create an array like this. Okay, suppose I will declare a range, and I will typecast it into a list, and I will put it into an array. Okay. Afterwards I can I can just do np.array a, and it will automatically be typecasted into a NumPy array, and that is called vectorization. Why? Because I am basically, rather than, and this is how we do it in classic way. Classic way means you take you access each single element in the array. uh, how much is this? 100,000. Okay, you access 100,000 elements in an array, and you assign a value to each and every one of them, which is needless to say very time taking. And in computer terms, it takes 15.44 seconds, which in computer terms is forever. Okay, you don't want it to take that long. So with vector, it takes 0.215 seconds, which is pretty good. Now we're finally moving on to the last leg of the session. This is matplotlib. We will again import it, matplotlib.pyplot. You can, we are basically importing a sub-module of the matplotlib library called pyplot as PLT, with the name PLT. We will declare a NumPy array like this. Okay. Okay, and this way you can create a plot, and then we will be using this very frequently in our sessions after this, to plot out numerical solutions that we get. Okay, so you can, this basically is saying 0 to 3 pi. Okay, it is 0 to 3 pi with a step size of 0.1. Wait. Okay, yeah, so with the step size of 0.1. So what is this is doing? It is creating an array of all these elements of 0 to 3 pi, 0.1, 0.2, 0.3 till 3.3 pi. Okay, why are we creating such a large array with such fine float numbers? You will see that in a moment. And y is equals to np dot sin x. So what I'm doing here is I'm creating an array. Okay, creating. Just give me 1 second. I'm sorry. Yeah, I'm back. Sorry about that. Okay, yeah, as I was saying. So it will basically create an array of step size 0.1 from 0 to 3 pi, and this thing will create an array. It will take each single x value in that array, and it will convert. It will take the sign of that value, and it will put it in this y array. And you can plot out these two arrays. You can basically what you're doing here. You're plotting out each single point x and y here. That is what this plt.plot function does, and it will show you this thing like this. Okay, so it looks like a very smooth graph. Okay, it looks like a very smooth graph. Okay, but if you reduce the step size to say 1, it looks like this. Okay, so in our sessions also we will be usually be taking very fine points, so to get a very smooth and as accurate graph as possible. Similarly here also, you can plot two graphs like this, side by side. This is basically the syntax that you need to look at. There's nothing much to explain here as such. You can label the axes. You can, create a legend here like this to check which is which, and this is very accurate because we know that sine starts from 0, cos starts from 1, at x equals to 0, and and both of them have a phase difference of about 90 degrees. It seems about right. Um, Here I can also create subplots. Subplots means I want to create one single plot inside, this thing. So, this exponential function, this cos function within one, graph without them overlapping. So this is all the functionalities of Matplotlib library. This is pretty much all that we will be using, but there are innumerable ways of making graphs, making beautiful charts and graphs and data visualization that I want you to look at, and I think in the repository here, yeah, I have also, yeah, I have linked this Matplotlib documentation. Documentation might seem very jarring at first. It might seem very, scary, but I assure you, once you know how to read documentation, this is the way to go for all your, whether be it coding knowledge or you want to learn new, maybe if you're maybe in circuit branches and you want to learn how to make a new, code a new some microcontroller that you have, this is the way to go. Okay, documentation. So this is Matplotlib documentation. This is NumPy documentation. Yeah, so this contains tutorials, how each single information about every single function that is there, how it works, stuff like that. Yeah. So you can go and look into that, and you can create 3D graphs, you can create bar graphs, you can create scatter plots, any pretty much anything and everything. But this is all we will be requiring, and that is why it's all I'm covering. Okay, are there any doubts now? This is the final call for doubts. So if you have any, please unmute and ask. Put in the WhatsApp chat, whichever is more convenient for you.